In this lesson, you will learn to work with imaginary and complex numbers. An imaginary number is defined by I equals the square root of -1. So if we take and square both sides, so I squared equals the square root of -1 squared, squaring and square root cancel one another out. They're opposite operations. So we're left with I squared equals -1. So it is good to know that I equals the square root of -1 and I squared equals -1. Let's simplify some radicals to make some imaginary numbers. So first we can rewrite this as the square root of -1 times 13. Well, we know that the square root of -1, so this portion is going to become I. And then the square root of 13, we have previously learned to simplify using prime factorization. 13 is prime, so you actually cannot simplify any further. So the I comes out because of square root of -1, that equals I, and a 13 has to stay in. You would not write it square root of 13I because you could think that the I is under the radical. So actually the I is going to go in front of that radical symbol. Let's look at example number 2. Here we have the square root of -144. Again, let's rewrite this as the square root of -1 times 144. We know that the square root of a -1 is an imaginary number, so I. The square root of 144, you should recognize that as a perfect square. You could also do prime factorization to simplify. But because square root of 144 equals 12, our answer would be 12i. The I does go after the 12, just like with any other variable. You write the coefficient first and then the variable. So our answer here is 12i. Let's look at example number 3. We have the square root of -180. So again, rewriting this as -1 times 180. We will need to do prime factorization on the 180. So divide by primes. 2 goes into 180. 2 goes into 90. 3 goes into 45. 3 goes into 15. And then 5 goes into itself. So our prime factorization will help us simplify the part of the problem that's the square root of 180. Because it is a square root, we will be looking for pairs. So we have a pair of 2's and a pair of 3's. For each thing you circle or each pair, that comes outside the radical. So we have the 2 times the 3. Also the I that all gets to come outside of the radical, and the 5 stays inside. Of course, we can simplify by multiplying 2 times 3. We have 6. I, and then the square root of 5. Remember, the I needs to go after that coefficient of the 6. That's our coefficient, but before the radical, so it's not mistaken to be inside the radical. Now let's look at complex numbers. Complex numbers are of the form a plus bi, where the a is the real part of the complex number and the bi is the imaginary part. Let's look at some examples. An example of a complex number written in the correct form: 3 plus 4i. 3 is the real and 4i is the imaginary. 4 minus 2i is also a complex number written in correct form. Even though it does not have the plus of bi, you could rewrite it 4 plus a negative 2i to make it in that plus of bi form. So 4 is the real part, and negative 2i is the imaginary part. Another example of a complex number, 1 minus I, the square root of 5. This imaginary part, as we previously learned, when we have the radical, we do have to put the I in front of the radical. So that still represents the imaginary portion of this complex number. Now for some non-examples. These are not written in the correct form of a complex number. So if you had 4i plus 7i, that is not in the correct form. You have an imaginary plus an imaginary, which would not be a complex number. That's really just an imaginary number. If you have 3i plus 2, again, this is not in the correct form because a complex number must be in the form a plus bi. Let's look at some examples of finding the sum or difference of complex numbers. So we have the example negative 7 plus 2i. We're going to add that with the complex number 5 minus 11i. Well, here we will be able to line up our real and imaginary numbers from each of the complex numbers and just combine them like we combine like terms. Combine the real parts and combine the imaginary parts. So negative 7 plus 5 is negative 2. And 2i plus negative 11i is negative 9i. So you will combine the real part and you'll combine the imaginary part of each of the complex numbers in order to find the sum. Now let's look at finding the difference. We have 3 minus 6i. We're going to subtract that with the complex number negative 2 plus 5i. Keep in mind that subtraction is the same as adding the opposite. So we're going to keep the first complex number the same. We're going to change the subtraction to adding and change each of the signs of the next complex number. Add the opposite. Keep the complex number, change the subtraction, and change the signs of the last complex number. Well, now it's just an addition problem. So again, we'll add the real parts and add the imaginary parts. Line each of those like terms up. So we have 3 plus 2 gives us 5. And negative 6i plus negative 5i gives us a negative 11i.